Okay, we have a lot to cover today, so I'm going to get started. Good morning. My name is Matt Yanchishin. Don't worry about pronouncing my last name. You can call me Matt Y. And I'm a solutions architect at Amazon Web Services. And I'm really excited to do this session today. It's doing a lot of different events and sessions at reInvent, but this is my favorite because together we're actually going to build something. We're going to try the famous live demo. We'll see how that goes. We have a video just in case. But together we're going to build a big data application. I was thinking of different ways we could do this, and I thought that the best way to learn about your first big data application was to build a big data application that leverages several services. So rather than stand up here and just tell you about the services that you could use, together we can actually use them together to do something real. So that's what we're here to do today. So unfortunately, I had to prepare for this session, so I wasn't able to attend the keynote today, but that Amazon Aurora announcement is amazing. It's our new high-performance relational database. And didn't quite make it onto my slides here, but it's an amazing and exciting new addition to our big data portfolio. So what you see here is the big data set of services at AWS. We have a number of services to allow you to collect and store and process and then automate everything you need to do with big data pipelines. It would be impossible in 40 minutes to cover every single one of these services, but what we'll do is just get your feet wet. We'll do a little introduction for the ones that we'll be covering in our application today, and then hopefully it'll generate some interest and you can go deep on some of the services. Personally, I do a lot of Elastic MapReduce work in the work that I do. I'm based out of New York. We work with a lot of life sciences companies and financial services companies, people who have big applications with a lot of data to process. So starting from the top with Collect, we have our Direct Connect service. And this service allows you to make a private connection between your co-location facilities and Amazon's facilities. So you can essentially build a private cloud if you want with no public-facing connectivity and have a private connection, a low-latency private connection between Amazon and yourself. This is really important for a lot of the businesses that I work with because it not only allows them to push a lot of data at scale into Amazon, but it also gives them that physical isolation that they sometimes require. There's a joke that sometimes FedEx is faster than the internet, so that's why we have AWS Import-Export. I don't know about you, but how many times have you had, I've had many occasions where I've had dozens of terabytes that I've needed to get up in the cloud, and on my little files line at home, that takes a while to upload. So that's why we have Import-Export. You can ship us the drives. And it's a great way to on-ramp onto big data applications on AWS because you can literally send us the hard drives and we'll load them up into S3 and Glacier and other storage systems for you. We also have a newer service called Amazon Kinesis that we're going to use today. And it allows you to durably store real-time incoming streaming data at scale. It's a really exciting service, and hopefully today you'll see it during the demo, how it works and how you can make it work for you. What most people do is they take data into Kinesis, and then they need to persist it somewhere durable. And that's why S3 is great, because it allows you to persist the data somewhere durable that's high performance that you can also use in your big data applications. And we'll see today how you can actually use S3 with Hadoop, with EMR, instead of using HDFS. And that combination of Elastic MapReduce, of EMR, with S3, that durable high-performance cloud storage, is really compelling. DynamoDB is our NoSQL data store. We're going to use it to store some metadata that allow us to checkpoint, and that just is a fancy way of saying if we're going to process a bunch of events in our feed in a big data application, we need to keep track of what we process. So DynamoDB is a great way to do that. It's a low-latency, high-performance NoSQL data store that's not expensive at all. We're not going to use Glacier today, but Glacier is S3's cousin. It's our cold storage service. It's a great place to store data that you may use one day. You're not sure if you need to use it today. I met a customer yesterday who has a pretty cool use case. They put all of their data in Glacier because they do analytics pretty rarely. And when they need to do analytics, they bring it out of Glacier and they persist it in S3 reduced redundancy storage, which doesn't give you quite the same high durability that you get with regular S3 storage. But it's a lot cheaper, and for his purposes, because he knows the data is safe in Glacier, he can keep it in Glacier and then put it in RRS and reduced redundancy storage and then process it there for a lot cheaper when he needs it. It's a really cool workflow. I really like that one. EMR is going to be at the center of today's demo. It's our Hadoop as a service. It allows you to run a cluster that can run Hadoop and a lot of applications on top of Hadoop, and we'll talk about some of them today. Redshift, our data warehousing application, we're going to push data from EMR into Redshift, and you'll see how that works. And then, of course, EC2. You can use our managed services, but you're free to use any tool that you want to use and build it up on EC2. Almost everything out there in the big data ecosystem can run on EC2. So this is what we're going to build. This is a pretty classic design pattern. And I think once you start working with big data, you'll see that this type of pattern applies to a lot of different verticals, a lot of different solutions, whether you're in marketing, digital analytics, and life sciences, and doing things like genomics, or finance, going through trades and stocks, et cetera. This kind of a design pattern where you're aggregating information, in this case logs, pushing it into some kind of a durable stream, in this case Kinesis, processing it, we're using EMR for this, and then persisting it in S3 and using Amazon Redshift to back your visualization layer. This is a really common design pattern that we see all the time. This is, of course, quite high level, but it's a great building block, a starting point for a pretty general purpose big data application. So what are we going to build together today? We're going to collect some log entries. I'm using a tool called Log4j, which is just a way to grab log entries and push them somewhere. In this case, we're going to push them into a Kinesis stream. We're going to launch a Hadoop cluster, and we're also going to launch a Redshift data warehouse cluster. We're going to use a Hadoop application called Hive that I'll talk about in a second to check out this data. What's really cool about running Hive on EMR specifically is you can actually access your Kinesis stream, your incoming streaming data, directly from your Hadoop cluster, and we'll show you how to do that. Then we're going to take the data, transform it a little bit, use EMR effectively as an ETL engine, do some transformation, and then push that transformed data into Redshift, and then run some queries against Redshift. So going back to that diagram for a second, it's going to kind of look like this. Log4j pushing some logs, Apache logs in this case, into a stream, using the Kinesis connector for EMR, for Hadoop, and Hive in this case, to query the stream directly, persist that data in S3, and then load in parallel into Redshift. A very common design pattern, and hopefully it forms a good building block for you to learn about big data. So now we're starting to get into the heavy text. That's a pretty, actually that's not such a nasty graph. I don't know how many of you worked with some of the marketing analytics log files can have like 50, 60 columns, And this is one of the big reasons why we do ETL, is because we need to clean things up. So say, for example, we had a log file like this from Apache, in this case, the Apache web server, HTTPD. And we had another web server, IIS or something else, or some obscure one that had the timestamp in another time zone, not UTC or not GMT. And we needed to normalize those timestamps so we could put them into a Redshift table and run a query against it. That's a classic data transformation problem. And that's kind of what we're going to address today. And you can use a tool like EMR and Hive or Pig or other Hadoop applications to normalize your data, to transform your data so that it can be ready for queries, so that you can take action, so you can derive benefit from it. So today we're going to be using the AWS CLI, the command line tool. Now I'm also going to show you what it looks like in the console, but you're going to be able to take this lab home with you and try it in your own account. It should only cost you a few cents, maybe a couple bucks maximum, to go through this entire lab. So feel free to take what I show you today and modify it for your own needs and purposes, and try it and try some creative stuff. And let me know. Get in touch. I'm always curious to hear what customers are doing and what you ultimately build out of this building block. But today I'm going to use the CLI just to show you how easy it is to run stuff using the command line. If you're not comfortable with the command line, that's fine, but it'll also give you a little glimpse on how easy it is to automate these workflows using things like the command line interface or the API or some of the lower level ways to launch resources with AWS. So let's start. So here I am in a console. I've actually logged into an EC2 instance. I've installed just the basic AWS command line. I'm using SSH to log into this instance. I have a mouse, that's maybe easier. Oops, sorry. They have logged me out. I'll get back in there. Okay. So this is the AWS CLI, the command line way to launch an EMR cluster, a Hadoop cluster. So you can see it's the AWS application, the type of AWS service I would like to launch, and I'm going to create a new cluster. In this case, I'm going to install the Hive application. I'm installing Apache Hadoop version 2, and it's going to be a 3-node cluster made up of 3 M3 extra large instances. There. Now let's go to the console. I can't actually see yet. There, so there's our cluster that started. If we look inside, you'll see that it's provisioning the 3 nodes that I specified. If I dig a little deeper, you can see it's installing the latest version of Hive. Our distribution of Hadoop. Hadoop is like Linux in that way. You use that word distribution with Linux. You have Debian and Ubuntu and Red Hat and these other distributions. Hadoop is kind of the same. On AWS EMR or Amazon EMR, you can run several distributions. It currently MapR and our Amazon distribution, which is pretty close to Apache. So if I look under steps, we have this concept of steps in Hadoop and in an EMR. And steps are really just tasks that you execute in sequence with your Hadoop cluster. In this case, we're just doing one step, and that's install Hive, which is the Hadoop application that we're going to use to run our queries. So this will take a few minutes to spin up, so let's go back. Next, we need to make an S3 bucket. Remember I said we're going to take all that data into a Kinesis stream, and then we need to persist it somewhere durably. Kinesis is a durable data store, absolutely, but the data only persists in a Kinesis stream for 24 hours. So you need to take the data out of your stream and put it somewhere, where it's going to persist and stay so that you can do analytics on that data going forward. So let's do that. In this case, I'm going to make a bucket called so that's a bucket I just made in my account. Again, I'm using the command line. I could have done this in the web interface. Let's go back to the web interface. Hit refresh. And there I should be able to see, there it is. There's my empty bucket. In case you don't believe me, the bucket is empty. It's like a magician up here. Next, we're going to make a Kinesis stream. And this is one of our newer services, and it's one I use almost every day. And this will be really the front door of our big data application. It's where those logs are going to be ingested into so that we can then take that data out and persist it and operate on it. So we're going to create a 2-shard Kinesis stream, and I'll explain what that means in a second. Oops. Oh, it already exists. Let's check it out. So I'm actually going to delete the old stream and create a new one in a second. And while we wait for this to delete, so Kinesis has this concept of shards, and that's how you scale your stream. What makes Kinesis really powerful is that it's elastic, like so many other AWS services. So say you have a bunch of log files coming in, you can actually size the throughput, the capacity of your stream in terms of how fast you can read and write by adding or removing shards on the fly. So by default, I'm starting with 2 shards. That'll give me a certain amount of megabytes per second that I can write to the stream. And we'll see how much that equals in a second once we build it. There, so let's delete it. Let's try that again. There, okay, so now if I go back to my stream, hit refresh, I should see it. We'll just let that create for a second. Next, we're going to make a data warehouse. And this part, I mean, creating a Hadoop cluster in a couple minutes is pretty cool, but for anyone who's worked with big enterprise data warehouses, this kind of blows my mind. You can make a data warehouse cluster, a columnar OLAP data store in just a couple minutes. And in this case, we're going to use the DW2 large. There's a free tier for Redshift, but if you were to do this even without the free tier, it would only cost you 25 cents an hour to run. And it gives you a fully functional SSD-backed cluster to run your OLAP workloads against, your analytics workloads. So let's spin that up. In this case, Just to walk you through it a little bit, I specified the node, which is kind of like the instance type that we're going to use for our Redshift cluster, so the DW2 large. It's going to be a single node cluster, but I could make this a 20, 200, whatever node cluster. The cluster limit for Redshift has actually grown recently. You can grow clusters up to 2 petabytes in size, and the performance really scales linearly the more nodes you add to your cluster. So it's really powerful. You can start small, and as your business succeeds or as your data grows, you can grow your cluster to meet the needs of your business. So just spat out some JSON to tell me about the details of my cluster. So we'll just go to Redshift here. So there it is, it's creating. And that'll just finish in a couple minutes. Meanwhile, my Kinesis stream is active, and it's a 2-shard stream. So you can see that I have write capacity of 2 megabytes a second and read capacity of 4 megabytes a second. To increase that, I would just add new shards, and it would automatically increase the aggregate capacity of my stream. Now let's do something. We've just launched a bunch of stuff, but now that the stream is active, let's push some data into that stream. So going back to my instance, what I've done here is I've pre-downloaded a big log. So this is the access log, and if I do the head command, which just shows you the first few lines of the log file, you'll see that's the Apache log that I had up on the screen before. So in reality, it probably wouldn't be a static file like this. It would probably be a rolling log that's growing over time. But Log4j can push the log as it changes, as entries get added in real time to your Kinesis stream. For the purposes of today's demo, I just took a big chunk of log, and we're going to push all those lines of logs into the stream. So we have a little Java application that'll do that. You can download this Java application. It's listed in the Kinesis documentation and in the EMR documentation. Oops. So this is writing the log entries, the log lines, into our Kinesis stream, 1 line at a time. So it'll go pretty fast. I think I have about 39,000 lines of logs. We'll let that kind of chill out for a second and check out the status of our clusters. So here we are back at our Redshift console. And it is up, it's available. So our cluster has been created. So we have a data warehouse in under 2 minutes. Let's go check the status of our EMR, of our Elastic MapReduce cluster, and it is also up. So you'll see that both nodes are running, and if we go down to steps, Hive has been installed. What's important to know about EMR is it's a cluster management tool, really, a high-level way to bootstrap and spin up EC2 instances. But it doesn't hide those EC2 instances from you. You have full root access to the underlying nodes. So if you're a Hadoop guru and you really want to customize things, you can SSH into your master node of your Hadoop cluster and make all the changes you want. And that's exactly what we're going to do. So if you look in your your EC2 console, you'll notice there's some new M3 extra larges here, and this is my Hadoop cluster that has been spun up. If I dig a little deeper, oops, you'll see that I can tell it's the Hadoop cluster because of the security group that has been assigned. That's the master node. So how do we connect to it? Well, EMR lists the public DNS of our master node, and we're going to SSH into it. Just give me a second to copy paste. And I'm also going to copy paste the private DNS, and I'll explain why in a second. Okay, well, that's still going. Let's let that hang out for a second. How many of you are familiar with SSH and have ever done port forwarding? Okay, good number. So what we're going to do is when we connect to the EMR master node, we'll just use standard SSH, but I'm going to use the -L command to do some port forwarding. And that's because EMR spins up some servers, some web servers, that allow you to view information about the cluster. And those ports and the ability to view the web servers are not available from the outside. They're not public. So by doing port forwarding, we can bring up those web interfaces locally. And that'll make more sense once you see it in a second. But that's what those extra commands are in the SSH command when I run it. I think that's enough records. All right. So let's get in there. So I'm just SSHing in, and you see that right there, oops, well, I'll do it again. See the -L. So what I'm doing is I'm forwarding 2 ports, and that's the ports that these web interfaces are running on, and you'll see what they look like in a sec. We'll also see if port forwarding works on this Windows laptop they just gave me. Okay, so let's run Hive. So this is what we just did. We just downloaded the logs, and this is the information you'll get in the lab, and I'll give you a link to the lab at the end of this session. And we use this Java application with log4j to push the log entries up into the Kinesis stream. So here's where we are. We've aggregated the logs in our Kinesis stream using log4j, and now we get to process them and transform them using our Hadoop cluster, our EMR cluster. So we just logged in, which I just showed you, using the -L commands to port forward, and we ran Hive. So what's Hive? Hadoop you can think of, in a lot of ways, it's like an operating system for big data applications. I think that's the easiest way to think about it. That's how I think about it. And within that operating system, you can run a number of applications. And each of those applications has different purposes. There's applications like HBase for NoSQL data stores that runs on your Hadoop cluster. There's an application called Hive. And Hive gives you a SQL-like, because it's not the full ANSI SQL language, but a SQL-like interface to run MapReduce jobs, to run jobs on your Hadoop cluster. There's another sort of sister application called Pig, which a lot of people use for data transformation, for text transformation. It's really good for that. And it was developed by Yahoo. It uses a slightly different language that's SQL-ish. And then there's a whole ton of other applications. But think of Hadoop as the base, the operating system for your cluster that can run all these different applications. Hadoop 2, which we support with EMR, comes with something called Yarn, and it has much better scheduling and resource management, so it can better run multiple applications and schedule all the resources between them. So let's see what Hive looks like. Oops. So there, I've logged into Hive, and you see the Hive console there. And I'm going to set some defaults. And this will tell Hive where my Kinesis stream is. So here I have the access key and secret key, and you can take a picture. I'll change them right after this session. And the region that we're working in, and then just some defaults to make Hive and Kinesis work well. Now we're going to create a Hive table. Now anyone who's worked with SQL in a database will understand the concept of a table. It looks very similar. You know, I'm sure most of you have done SQL before. We're creating a table to hold the data. What's different with Hive is that it's schema on read. So with most relational databases, when you create a table, you load data into that table, and the data has to match the schema, and it stays fixed in that schema. With Hive, it's a little different. You effectively define the schema immediately before an operation. You say, hey, there's some data over here, and this data I know takes this shape, so I'm going to define what the shape is before I run an operation. So before you do a select, for example, you can define the schema and then select against that schema. So in this case, I know what the log looks like. It's a comma delimited file with these columns, and that crazy string you see down there is just a regular expression that represents the format of the Apache log. So what you can do is come up with different schemas for different log types or different input types, and then on demand, map those schemas to whatever data you're processing. So it's really powerful in that way. Now, importantly, at the bottom there, you'll see that we have stored by Kinesis storage handler. And that means that we're actually going to pull data out of the Kinesis stream directly. And this is what makes EMR so compelling, is because it has integration with other Amazon services like Kinesis. You can also pull data out of S3, and we're going to see that in a second. You can write to S3. You can also use DynamoDB. So you're not limited to just HDFS, which is typically what you would use, the distributed file system that is the default, if you will, for Hadoop. You can use multiple data stores with EMR with Hadoop. And today we're going to use Kinesis and S3. So the table takes no time to create because we're not actually moving any data. We're just defining a schema in the Hive metastore that we'll later manipulate, or we'll later use to manipulate the data. So let's make sure it worked okay. Now we're down to live demo crunch time. I'm going to select just a single record from the Kinesis stream. And EMR is going to go out and say, hey, Kinesis, here I am. Here are my credentials. Can you show me one row from your stream, one item? Tick, tock, tick, tock. Hive is famous for a lot of things, not for being fast. We'll let that, there we go. So you might recognize that as a line from the log file. So it's reached into the Kinesis stream, and it has pulled this out. Now this is, I know, kind of white on black and not that exciting to look at, but it's exciting, I promise you. Because in order to access a stream or data stored in similar technologies like Kafka, that takes a lot of code. And you need to know about iterators and how to reach into a stream and pull things out. This makes it super easy. And we have big companies using EMR just for this purpose, to quickly query against their Kinesis streams. They have real-time data coming in about security or about logs or whatever, and they can use EMR to quickly query their Kinesis stream. It's like a SQL interface for Kinesis. And that alone, if we stopped right there, is pretty cool. But we're not going to stop right there, don't worry. So we need to persist this data somewhere, right? Got a little bit ahead of myself there. I'm doing a lot of talking, but I think talking is better than slides anyway. So this is the table we just created. We did that test. So here we are, and we have log4j. It's pushed up in the Kinesis stream, and then we've used EMR to reach into the Kinesis stream. We've connected EMR and Kinesis via Hive. But remember, the data is only persisted in the Kinesis stream for 24 hours. So we need to take that data out and put it somewhere so that we can have it there after the 24-hour window and also do more advanced queries against it. So we're going to stick it in Amazon S3, which is 11 nines of durability, a great, cost-effective, and high-performance place to stick your data. So to do that, I create an external Hive table, and if you look at the last line, the data for this table will be stored in that bucket I created. Remember when I created that S3 bucket, it's going to store the data in the bucket. So when I run a query against it and I write to this table, it'll write the data, in this case from the Kinesis stream, to the table to the bucket in S3. So again, because we're not moving data right now, that happens really quickly. We're going to do a couple other things to show you the benefits of Hive and some features. I'm going to set some variables here, some parameters rather. The first one says partition mode. So we're going to use Hive to partition the data. So instead of grabbing everything and sticking it in a big fat file in S3, it's going to split it up into chunks. And this is important because Redshift, where we are ultimately going to load this data, can load data in parallel into the cluster. And as we all know, it's much, much faster to load data in parallel than one file at a time. So we're going to use Hive to split things up into a bunch of little files that are going to sit in our S3 bucket so they can be loaded all at the same time into Redshift really quickly. Hive is also going to compress the data. So we're going to have little gzip compressed chunks that we can then load into Redshift quickly. And they'll load quickly because they're compressed and they're smaller. So let's do it. So I ran an insert command, and this is going to now take the data from the Kinesis stream, and it's going to insert it into S3. And while it's doing that, it's going to do a little tiny transformation there where it's going to change the hour field into a normalized timestamp that Redshift can recognize. So I'm doing a very simple data transformation. And then it's going to persist it in S3 and chunk it up and gzip it. So we will have a transformed, ready for parallelization data set. We're doing ETL. It wasn't that hard. We're now using EMR as an ETL engine. Now, I'll be totally honest with you. Using Hive for data transformation is not its strong suit. You know, most people would use Pig and other applications for this, but it's a great place to start. Hive is more like a data warehouse. If you've ever worked with SQL, you'll know that SQL is not amazing for string transformation necessarily. There are other better tools out there for that, but it does the trick if you're doing stuff like this. If you do want to do more complex string transformation, start to look at some of the other Hadoop applications. Start with Pig. It's a good place to start. So what Hive does is it's now transforming that SQL command, that insert SQL command, into a MapReduce job. And it's taking that and it's farming out the work to the cluster, to all the nodes, in this case 3 nodes of the cluster. So it's looking at the data set, it's taking that data, and it's figuring out what kind of transformation it has to do and then spreading that work and the data across the nodes of the cluster. And that's really what Hadoop does. It's kind of a cluster management distributed computing tool. And Hive is a higher level tool, so you don't have to write complex Java jobs. It does that for you. Based on the SQL you define, it goes and runs those Java applications on the JVMs running in the slices on the Hadoop nodes. So in other words, it makes Hadoop a lot easier. Now, if you need to do stuff that is not as easily represented in SQL, or if you want to really optimize your performance, that's when you get into writing custom MapReduce jobs. But between you and me, I use Hive and Pig like almost for everything these days. I haven't written a custom Java MapReduce job since, well, maybe yesterday, but still, it wasn't that complex. So this will take a while, so let's go back and look at the slides. This is where the live demo gets really interesting, because I actually don't know if this is going to work. But let's see if port forwarding will work on Windows, where I'm going to look at the Hadoop web interfaces. Now remember, when we connected with SSH, we port forwarded some ports. And all that means is that it exposes the ports as you define them on your computer, so you can load up localhost and see the web interfaces that are actually hosted remotely where you've SSH'd into. So let's see if this works. Oops. Oops, that was the wrong address, sorry. Maybe not. Okay, well that's not working, but that's okay. I can show you what it looks like in the video after. So meanwhile, the Hive job has finished, and if we scroll up a little bit here, what it's done is, this is the partitioning that's happening. So I define the partition, in my insert query, you'll see this in the lab when you take it home, I define the partition to be the hour in the timestamp. So it's going to split the files based on the log entries, based on the hour. So everything that happens at 11 p.m. goes in one S3 prefix, everything that goes in, and so on and so forth. So let's look at our S3 bucket that we created to actually see that. So we'll go to the bucket that we created. So there's our demo. Remember, it was empty before. We go into EMR demo and the output, and there's our partitions. And each side of each one of these partitions is a gzipped chunk of our big log file. So remember, it was one big access log file, and we were pushing individual log lines in. And now we've done a transformation, and we've pushed it into S3. Success. So we did all this. So we're here. We have transformed the data, and we've persisted the data into Amazon S3. Now, Hue is something that was just released, and I don't have it on this cluster because actually when I built this cluster for this presentation, we hadn't come out with a Hue feature yet. It just came out a few days ago. But if SSHing into a master node and running Hive queries in the console is not your idea of a good time, Hue is for you. It's a web interface that makes EMR much, much easier to use. And what's really cool about Hue is it has a file browser that is S3 compatible, so you can actually navigate your S3 buckets from within Hue. You can run Hive queries, you can run Pig queries, you can even visualize the data. So I just wanted to give a quick plug to Hue because the EMR team has put a lot of great work into getting this ready. And now when you start your cluster, and you can do this with the lab when you do this at home, you just pick Add Hue. And just like I added Hive as an application, you can add Hue. And then you can open up the Hue web interface, and you'll have a very pretty, easy to use, and yet powerful web interface for Hadoop. But today I thought we'd get down and dirty, so we're using the SSH. So we saw our output files there in S3. We've properly partitioned them. So now we can connect to our Redshift cluster and take these gzip chunks that we've made with Hive and load them into Redshift. And again, loading them into Redshift is going to be efficient because when we issue a copy command to load into Redshift, it does it in parallel. So we have a ton of files, and we can load them in parallel because they've been split and gzipped. And Redshift understands how to deal with compressed gzip files, so that's not a problem for it. So I'm going to use, again, the command line, forgive me, to connect to the Redshift cluster. So I'm going to use the psql as part of the Postgres package to connect. But importantly, you can use any tool to connect, and I put a couple of my favorites down for you there. Aginity has a great workbench for Amazon Redshift, strongly recommended if you're a Windows user. And if you're not a Windows user, you can use SQL Workbench J, and there's other ones out there as well. And they provide an easy way to connect to a Redshift cluster. And Redshift is a data warehouse, but it's JDBC, ODBC compatible, so long story short, pretty much any application that you can use a Postgres driver and that can speak over JDBC, ODBC can connect to your Redshift cluster. So in this case, I'm using the Postgres native client to connect to my Redshift cluster on the command line. So if I go back to my Redshift table, there's Redshift. That's the Redshift endpoint, the address of my Redshift cluster. I'll copy it. I'm going to quit out of Hive. And I'll put the host name of my cluster. And I have port 8192, username master. The database I created was called demo. Oops, oh, I didn't install Postgres, awesome. Real-time, I'm sorry. Good thing the internet's good here. There we go. What's the password? It's secret, it's master123. And here we are connected to the cluster, okay? So now what we can do is create a table to hold the data. And again, this is just ANSI SQL. So this is a slightly different version of the table from the one we created for Hive because we have transformed things now. And when I did the Hive transformation, and you can see in more detail when you have more time when you do the lab, is we didn't take all of the fields. I didn't need all of the columns in that log file. So it's a subset of the columns and also that transform timestamp that we transform with Hive. I define a distribution key and a sort key, which allows Redshift to efficiently distribute the data across its cluster nodes. In this case, it's a single node, so it's not such a big deal. And then a sort key so we can have more efficient queries because data is sorted in the order that we will usually need it in. Lastly, let's copy the data in. So this copy command, remember, runs in parallel. So what I'm doing here is copying Apache log, so into the Apache log table, from the location in S3 that I just showed you with all of those gzip files. And I'm telling Redshift, these are gzip files, hence the gzip at the end. And the delimiter of these files is a /t, a tab. So Redshift knows this is a tab delimited gzipped file that will correspond to the columns that I defined in that table there. Let's wait for that to load. We created the table. We're loading it into Redshift. And then we'll run some queries. So there, the data is loaded, so we can run some queries. So in this case, I'm just going to do a simple query. This was an Apache log, so I'm going to select the host name and the request, the web request that was made for this web server, where the host was a specific IP address. So show me every request that this guy made. Boom, here we go. Now this is on the console, not very pretty, but because Redshift supports JDBC, ODBC, and because it uses ANSI SQL, and because it uses the Postgres drivers, you can use pretty much any BI or visualization tool that you're using today. So I'm sure a lot of you use Tableau, MicroStrategy, Jaspersoft, Qlik, Excel. All of these tools will work natively with Redshift. Now, interestingly, they'll also work with Hive and EMR. Hive and EMR also have JDBC and ODBC drivers and access. And in case you saw, Hive is sometimes a little higher latency, in other words, a little slower for querying. Redshift is much, much faster, and it supports the full ANSI SQL language. So you can do your complex analytical queries that you've been doing for years on other data warehouses, and they'll work on Redshift. Your star schemas, your snowflake schemas, most of the time, none of that has to change. You can just take your data set, plonk it into Redshift, and start running queries from Tableau or whatever right away. And the query time is very fast. Now, that took about a second run, which maybe seems slow, but that's because Redshift compiles the query or the query plan the first time, so it knows where to go get the data and how to properly execute the query. Subsequent executions of those queries, like you just saw, are super fast. So if you have a predictable query that you're going to run or a predictable set of queries, Redshift will be extremely fast all of the time. So there we go. Let's go back and see where we are. Again, we have partners. If you go to the AWS Marketplace, we have partners who have BI and visualization software that you can use that are compatible with both Redshift and EMR. And I recommend you check them out. I'll have a link up in a second. But we've done it. In just a few minutes, live, we pushed log data into Kinesis. We aggregated that data. We persisted that data. We transformed that data. And we loaded it into an enterprise-grade data warehouse and ran some queries against it. And from where I'm standing, that's pretty cool. So if you would like to talk more about this, if you have any questions, please come find me outside. I'll hang out for a good half hour. So I'd love to hear from you. I love hearing about use cases. And, oh, I forgot to put the link up for the take-home lab. Most important part. So I see everyone's taking pictures. So someone tweet that so that the rest of you have it. And grab the take-home lab, give it a spin. I'm going to go change my IAM keys right now. And it's been great talking to you. So thanks a lot for your time.